user group in Malaysia. While we always strive for our applications to operate flawlessly for our users, the reality is that things break sometimes. In this session, we will explore various methods and techniques to ensure the reliability of our applications, including how to manage failures and prevent data loss. It's very important to know how well your software is working and functioning. And you can achieve these insights by monitoring, logging, and alerting. The system reliability depends on different performance metrics like availability, durability, and scalability. Now let's talk about how we can design for reliability. First, you have to avoid single point of failure. You can do that by replicating your data and having a multi-instance deployment. And always make sure that each unit in your architecture can handle the extra load. Don't make any single unit too large, and make your units stateless clones. Next, pay attention to correlated failures, which often occur when multiple components or systems fail at the same time. For example, if a single machine fails, all the requests served by this machine will fail. If a top-of-rack switch fails, the entire rack will fail. If a single zone or region is lost, all the resources in it will fail. Now, to avoid correlated failure, you can start by deploying to multiple zones or regions. Split responsibilities into components and spread across multiple processes. Always design independent, loosely coupled services. Be careful of cascading failures, which often occur when a failure in one part of the system increases the probability that the other portion of the system will fail. Let's say you have two servers. If one server fails, the other server will be overloaded handling the capacity of the failed server. To avoid cascading failures, you can configure health checks on the load balancer or readiness and liveness probes in Kubernetes to detect and replace the unhealthy instances. Make sure that the new instances start fast and ideally don't depend on any system or backend to start up. Now let's talk about query of death, which is inefficient database query that can slow or crash the system by over-consuming the resources. Identifying this type of issue can be tricky and requires good monitoring and logging to find the root cause of the problem. And always make sure that you are sending notifications to the developers for this kind of issue to take a look at. Now let's talk about the positive feedback cycle overload failure. So basically you try to make the system more reliable by adding retries, but instead you create a potential for an overload. Now the problem with issuing retries is that you don't know why the first request failed. Is it because the service you are calling is already overloaded? If this is the case, then a retry can add more load to an already overloaded service. If you want to use retries, you can wait a while between attempts, wait a bit longer after each time the request failed, and set up a maximum number of requests. Use lazy deletion to reliably recover when users delete data by mistake. With lazy deletion, a deletion pipeline is created, and you can restore the data within a predefined time period, and this will protect against any mistake by the user. Next, the data will be moved to a soft deletion phase where user support can recover or restore the data, and this will protect against any mistake by the application. And finally, the data will be permanently deleted, and you only can restore the data using your backups or archive. Let's talk now about disaster planning. You can achieve high availability by deploying multiple servers to multiple zones in a region. Then orchestrate your servers using auto-scaling groups and create a failover for your database in another zone in the same region, or use distributed databases like DynamoDB and Amazon Aurora. The auto-scaling group will evenly distribute your servers across zones in the region specified. For objects stored in S3, you can use cross-region replication to replicate your objects across multiple regions and get higher availability. If you are using Amazon RDS, you can use multi-AZ deployment where a replica will be created in another zone in the same region as your database. If the primary instance is unavailable, it will automatically switch to the failover instance. Just keep in mind that using multi-AZ deployment can double the cost of your database. If you are using DynamoDB, you can use global tables to replicate your tables across multiple AWS regions and get higher availability. Keep in mind that deploying for high availability increases cost. You can run risk-cost assessment like this one in this slide to evaluate the cost of distributing your resources across multiple zones or regions. Your disaster recovery strategy depends on the business impact, recovery time objective, and recovery point objective. A cold standby is acceptable with forgiving recovery time objective. You can create snapshots, machine images, and data backup in a multi-region storage. You can, if the main region failed, you can spin up new servers in the backup region and then route all the traffic to the new region. On the other hand, the hot standby is more about creating auto-scaling group in multiple regions, storing your unstructured data in multi-regional buckets, and for your structured data, you can use multi-regional databases such as DynamoDB and Amazon Aurora. When you are doing disaster planning, brainstorm ideas that might cause data loss or service failure. Your RPO and RTO will be major factors in determining the recovery process that must be implemented. In this slide, we have two services. You have the order service, which is very critical, and you have the recommendation service, which is useful but not that critical. Based on your disaster scenarios, formulate a recovery plan and create a backup strategy based on risk, recovery time objectives, and recovery point objectives. Communicate the procedure for recovering from failure, and always test and validate the procedure for recovering from failures. And finally, prepare your team for disasters using drills. These steps is very important, yet it's frequently overlooked. Practicing recovery is essential to ensure that the processes and procedures in place are effective in achieving the recovery point objectives and the recovery time objectives. You can follow the reference I attached here to read more about chaos engineering. So, in this session, we learn how to design highly available, durable, and scalable services, implement fault-tolerant system by avoiding single point of failure, cascading failures, and correlated failures, and then we discuss different disaster planning strategies. Thank you so much for attending this session, and please don't forget to complete the session survey. And if you have any question, you can find me on LinkedIn, and I will be happy to have a chat with you.